Hey everyone, it's Justin again. In this lesson, we're going to be learning about frequency tables, which are another method of representing a sample space. By the end of this lesson, you will be able to read frequency tables to calculate probabilities. First, we'll learn how to read frequency tables, and then we'll complete 2 example problems. Until this point in our probability unit, we've been considering either standard sample spaces, like a deck of cards, or we've been given information in a list, like this. As sample spaces get larger and more complex, lists can get very long and just plain inefficient to work with. This is especially true for sample spaces that have multiple characteristics that overlap, like this one. These types of sample spaces can also be represented in tables to help make the information easier to interpret. Let me show you. This listed sample space says that an animal shelter is cataloging all of their animals. They have 22 black dogs, 4 white dogs, 16 brown dogs, 9 black cats, 7 white cats, and 3 brown cats. There are 2 main groups of characteristics, or variables here. The species of animal, dog or cat, and the color, black, white, or brown. We're going to use these 2 variables as the rows and columns of the table. Each box inside the table represents how many animals have both characteristics. So this box would be the number of black dogs, which is 22. What would this box represent? This box would be the number of black cats, which is 9. Pause the video here and try to identify and fill in the last 4 boxes. Your table should look like this. One extra beneficial part of tables is that we can add a row and column for the totals of each characteristic. If we look at just black animals, there are 22 dogs plus 9 cats, so 31 total black animals. How many total white animals are there? 4 white dogs and 7 white cats makes 11 total white animals. There are also 19 total brown animals. This box represents the total of this row. So all 31 black animals plus 11 white animals plus 19 brown animals makes 61 total animals. We can also total by the rows or the type of animal instead. This row represents all of the dogs in the shelter. So the total number of dogs is 22 plus 4 plus 16, which makes 42. For the total number of cats, there are 19. And if we look at this bottom box of 61 again, we can see that 42 plus 19 also makes 61. So this bottom right box represents the total of all of the animals represented in this table. It doesn't matter if we categorize and find their total by the color of the animal or by the species. We call tables like this frequency tables because the numbers in each box represent how many outcomes meet each criteria. Let's practice interpreting these with a couple of example problems. Our first example problem says this frequency table represents survey results on people's preferred vacation types. If a person is selected at random, what is A, P of under 18 given beach, and B, P of mountains or over 18? And we have our nice frequency table here where the rows represent age and the columns represent the type of vacation. Before we start, let's get our bearings with this frequency table. This box right here is 13. What does this 13 represent? This is the number of people over 18 who like the mountains. And what does this 32 represent? This is 32 total people of all ages who like the city. One more. How many total outcomes are there in this entire sample space? 86 is the total of all the people who responded to the survey. Now that we know what this table represents, let's start with part A. Part A is asking for the conditional probability that a randomly selected person is under 18, given that they like the beach. We can tell this is conditional probability since it has that bar in the middle between the criteria and the condition. With this condition, what is the total number of possible outcomes? Here we are limited to only the people who like the beach. So instead of looking at this entire table, we are now just focusing in on this beach column. So how many total people are there who like the beach? That'd be the total box down here, so 34. Out of just the 34 people who like the beach, how many meet the criteria of being under 18? The people who are under 18 and like the beach would be this box. So 12 people. We can simplify this fraction by dividing the numerator and denominator by 2 to get a final probability of 6 over 17. Let's try part B next. P of mountains or over 18. How about you give this one a try on your own? Since this criteria is mountains or over 18, be very careful that you're not double counting any outcomes. Make sure to check if there's any overlap to account for. Pause the video here and try this out now. There's no condition in this problem, so we are considering the entire sample space, which is 86 people. Of those 86 people, how many like the mountains or are over 18? Well, this column represents all of the people who like mountains, which is 20 people. And this row represents all the people who are over 18, which is 58 people. Hey, this is actually really convenient. We can use the frequency table as a tool to help see how these groups overlap in this box right here. 13 people both like the mountains and are over 18. So these people are being counted twice right now. We need to subtract 13 to get rid of the overlap. So 20 people who like the mountains plus 58 people who are over 18 minus the 13 people who are overlapping in both groups makes 65 outcomes, or people who meet this criteria. 65 over 86 cannot be simplified, so that's our final answer. As we're starting to see, frequency tables have some benefits over lists of outcomes, particularly if you find visual information much easier to handle. Let's do one more example problem to get a little more comfortable with frequency tables. This second example says this frequency table represents the length of people's commute to work based on their method of transportation. If someone is picked at random, what is A, P of bike, and B, P of bus given greater than 45 minutes? We also have our frequency table here where the rows represent the length of the commute and the columns represent the method of transportation. Why don't you pause the video here and give this problem a try on your own? Part A asks for the probability that a person commutes by bike. Since there's no condition here, we're using the entire sample space. In this frequency table, that's represented by this total box here, which has 77 people in it. Out of those 77 people, how many of them are someone who commutes by bike? I'm just gonna take a look at the bike column and look for the total, which is 15. This fraction can't be simplified, so P of bike is 15 over 77. Part B asks for the probability that a person commutes by bus, given that their commute is more than 45 minutes. We have conditional probability here, so we are only looking at people whose commute is longer than 45 minutes. That means this row right here is all we need to worry about. how many total people have a commute longer than 45 minutes? The total for the more than 45 minutes row is 15 people, so that's our denominator. Of those 15 people, how many commute by bus? That would be just these 8 people in the bus column. So our probability is 8 over 15. I want you to consider the alternative to this frequency table for a second. If this sample space was presented as a list, it would look like this. Woo! That is a long paragraph. So using a frequency table for this scenario really helps to make the outcomes a lot more readable. Frequency tables are just another way of representing a sample space. Each box represents the number of outcomes that meet the criteria of the row and column. One great way to make sure you're understanding what a box represents is to point at the row and column that represents the criteria you're looking for, and then follow them along to find the box where they meet. Remember, where the totals meet represents the overall total number of outcomes in the sample space. There are a few more opportunities to practice in your PDF before you move on to your practice game. So take your time and read those tables carefully. I'll see you next time.